Morning! Welcome to another session of Valenzuela Live Facebook live streaming in Mathematics 10. We are now at quarter 4, week 8 with the topic Other Statistical Methods in Analyzing and Interpreting Research Data, specifically measures of position and measures of central tendency. At the end of this session, you are expected to use measures of position and measures of central tendency in analyzing and interpreting research data. Let us start the lesson with a quick recall of some concepts you have learned in statistics from your previous grade levels. Your task is to choose a reaction that corresponds to the correct answer. Just hit like, love, or haha, react button. You have 5 seconds to choose your reaction. Are you ready? Let's start. What is the term that refers to the sum of the data divided by the number of data? Is it like, love, or haha? You've got 5 seconds. Go. Alright, time is up. If you reacted like, good job. You're right. Let's move on to number 2. Which of these measures divides the score points into 4, 10, or 100 equal parts? Is it like, love, or haha? You've got 5 seconds. Go. Time is up. If you've hit the love react button, amazing. You are correct. Let's have the next one. What term refers to the number which occurred most frequently in the data? Is it like, love, or haha? 5 seconds. Go. Time is up. If you've hit the haha react button, awesome. You are correct. Let's proceed to number 4. What term refers to the middlemost value of the given set of data? Is it like, love, or haha? 5 seconds. Go. Time is up. If you've hit the love react button, you are right. Let's go to the last one. Which of these divides the distribution into 100 equal parts? Is it like, love, or haha? You've got 5 seconds. Go. Alright, time is up. If you hit the heart react button, nice. You are correct. Good start, grade 10 students. It seems that you have enjoyed your previous statistics class a lot. Let's carry on your enthusiasm with this next activity. At this point, let us see how good you are at analyzing and choosing what's best to apply in each situation. Your task is to read and analyze the situations carefully and choose the best answer by reacting like, love, or haha. You will be given 5 seconds to choose your answer. Are you ready? Let's begin. A milk tea shop owner wants to know which flavors rank below 25%. What measure is best to use in this situation? Is it like, heart, or haha? 5 seconds starts now. Time is up. If you've hit love, bravo, you are correct. Next. A jeepney driver wanted to know the average fare he collected in a single round trip. What specific measure is best to use in this situation? Is it like, love, or haha? 5 seconds, go. That's it. If you've hit like, awesome. You're right. Let's proceed to the next one. A shoe store owner wants to know the most saleable shoe size among his customers. What specific measure is best to use in this situation? Is it like, love, or haha? 5 seconds, go. Time's up. If you've hit haha, amazing. You're right. Next, we have an employee in company A has a record of the ages of his co-employees and wishes to know the middlemost age among them. What specific measure do you think is best to use in this situation? Is it like, love, or haha? 5 seconds, go. Alright, if you've hit love, good, you are correct. And that ends our first activity. How was it? I hope your analytical skills have been activated somehow. You will surely need more of this as we go along with the lesson. Let us now proceed to statistical methods in analyzing and interpreting research data, starting with measures of position. Measures of position for ungrouped data. If you still recall from your previous lessons, measures of position includes median, quartile, decile, and percentile. These measures divide the distribution into 2, 4, 10, and 100 equal parts. Let us take an example from the previous activity and try to analyze and interpret the data. Let us consider this problem. A milk tea shop owner wants to know which flavor ranks below 25%. Considering the table, we have the milk tea flavors in the first column and the number of customers in the second column. Since this problem requires rank or position, we can absolutely apply the measures of position. First, we must arrange the following data in increasing order. What must be the order of the data? Nice. We have 6, 6, 7, 7, 8, 9, 9, 10, and 11. What's next? How do we determine which of these arranged data belong to the 25%? Great! We are going to use the locator formula. L equals n times k over 4. Now, what is the value of our n and k? Exactly. Since our n is 9, the number of observations, and we know that 25% is the lower quartile or Q1, or also percentile 25, let us take the subscript 1 as our k. Simplifying this, we will obtain L equals 2.25. The result is not an integer, so we take the next whole number, giving us L equals to 3. This means that Q sub 1 is found at the third position in the set of data. And Q1 is equal to 7. Thus, the following flavors that are below the 25% of the data are cookies and cream and classic milk tea. Did you get it? If you have questions, feel free to drop them in the comment section. Aside from measures of position, research data can also be analyzed and interpreted by describing its center of its distribution. The measures of central tendency for ungrouped data. A measure of central tendency, also referred to as measures of center or central location, is a summary measure that attempts to describe a whole set of data with a single value that represents the middle or center of its distribution. One of these is the mean. Mean for ungrouped data. The sum of the value of each observation in a data set divided by the number of observations. This is also known as the arithmetic mean. Let us try an example. The data below are the fare collected by a driver in a single round trip. What is the average fare? Based on the definition earlier, what do you think is the formula that we can use? Perfect. To solve, we will use the formula x bar equals the summation of x divided by n, where x represents each observation and n represents the total number of observations. Substituting all the given data, we will have 12 plus 9 plus 9 plus 15 plus 19 plus 10 plus 12 plus 9 plus 11 plus 10 plus 14 plus 9 plus 10 plus 13 plus 12 plus 10 divided by 16. We have x bar is equal to 184 divided by 16. Thus, we obtain 11.50. This means the average fare collected by a driver in a single round trip is 11 pesos and 50 centavos. Now, let us proceed to the next measure of central tendency, the median for ungrouped data. The median is the middle value in the distribution. When the values are arranged in ascending order or descending order. Let us try an example. Consider the following employees' ages below. What is the middlemost data? To solve, arrange the given data in increasing or decreasing order. What is the order of the data? Great! We have 21, 23, 25, 27, 31, 31, 35, 36, 38, 38, 40, 41, 42, 43, 45, 49, 50, and 58. Notice that the number of observations is even. This means there are two middlemost data, which are both 38. If this is the case, what should we do to obtain the median? Amazing. Take the average of the two middlemost data. We have x tilde, represented as median, is equal to 38 plus 38 all over 2. Simplifying, we will get 76 over 2 or 38. This means that half of the employees are above 38 years old, or half of the employees are below 38 years old. This time, let's have the mode for ungrouped data. It is the value that occurs most often in the data. Let us try an example. The data below are the shoe sizes of the customers in a shoe store. Which shoe size is saleable? To solve this, we need to identify which size occurred most often in the given data. In this case, the arrangement of the data in increasing or decreasing order is optional. We have size 9 as the most frequently occurring size. Our x hat or mode is equal to 9. This means that the saleable shoe size is 9. Did you get it? If you have questions, feel free to drop them in the comment section. We had just finished discussing about the measures of position and the measures of central tendency for ungrouped data. Note that when the number of observations become higher, it is not practical to apply the concepts of ungrouped data. This is where the group data for the measures of position and measures of central tendency comes in. Let us start with measures of position for group data. The formula is Q D P sub K equals LB plus the quantity of L minus CF all over F times I, where Q, D, and P represent quartiles, deciles, and percentiles. LB represents the lower boundary. L is for the locator position, where L equals Kn over 4 if quartile, or 10 for decile, and 100 for percentile. Also, N is the total frequency and K is the desired position. Next is the CF, which is the cumulative frequency before the class group. I is the class width or class size. And lastly, F is for the frequency. To understand how this formula works, let us have an example. The table below shows the allowance of 43 students. Those belonging to the bottom 30% will receive financial assistance. What should be the allowance required to be able to be a beneficiary of the program? To solve this problem, we should be able to complete the frequency distribution table, specifically the column for cumulative frequency. Let us begin filling in the rows by copying the frequency of the lowest class interval. We write 7. Next, add 7 to the frequency of the next interval. We get 16. Add 16 to 6, we obtain 22. 22 and 11 gives us 33. Lastly, 33 and 10 yields 43. Note that the data in the last row of the cumulative frequency should be equal to the number of observations represented by n. Since the frequency distribution table is already complete, we can now start the process of solving the problem. For us to determine the values, we should begin with the locator formula. L equals n times k over 100. What is the value of our n? Good. N is 43. Next, what is the value of k? Notice that our keyword here is the bottom 30%. In this case, what is its equivalent in percentile? Great! It is P sub 30. Thus, we will take the subscript 30 in place of k. Then divide it by 100. Simplifying, we will obtain 12.9. Or, now, let us look at the cumulative frequency column and select the data greater than 13 for the first time. That is 16. We then take the class interval 21 to 40 as our kth class. LB can be determined by subtracting 0.50 from the lower boundary of the kth class, which is 21. Thus, we get 20.5. Our CF is 7. F is 9. And I is 20. Now that we have completed all the needed values, let us use the formula. P sub k equals LB plus the quantity of L minus CF all over F times I. By substitution, we have P sub 30 equals 20.5 plus the quantity of 12.9 minus 7 all over 9 times 20. We can solve this using a scientific calculator or the built-in calculators in your smartphones. Feel free to join me solve the problem using calculator. Are you ready? Let's begin. If you are using the Casio 991 ES Plus model, you can input the values this way. Input 20.5 plus symbol, open parenthesis, the fraction key symbol. On the numerator, input 12.9 minus 7. On the denominator, input 9. Close parenthesis, multiplication symbol, then 20. Convert to decimal, press SD. The answer is 33.61. If you are using your smartphone calculator, you can type the values this way. First, 12.9 minus 7 equals 5.9. Then divide by 9 times 20 plus 20.5 equals 33.61. Thus, P sub 30 is equal to 33.61, or this means the students should have an allowance of less than or equal to 33 pesos and 61 centavos to be a beneficiary of the program. At this point, let us explore the formulas for the measures of central tendency for group data. The formula for the mean of group data is x bar equals the summation of f times x all over n, where f is the frequency, n is the total frequency, x is the midpoint or class mark, and summation of x is the sum of the product of the frequency and midpoint or class mark values. Next is the formula for the median of group data. X tilde is equal to L sub MC plus the quantity of N over 2 minus less than CF all over F sub M times I, where L sub MC is the lower boundary of the median class, N is the total frequency, CF is the cumulative frequency before the median class, F sub M is the frequency of the class median, and I is the class width. Let us now talk about the formula of mode for group data. X hat is equal to L sub MO plus the quantity of A over A plus B times I, where L sub MO is the lower boundary of the modal class, A is the frequency of modal class minus the frequency before modal class, B is the frequency of modal class minus the frequency after modal class. I is the class width or class interval. The table shows the monthly electricity bill of selected households in Malinta for the month of April 2021. Let us calculate and interpret the mean by completing the given frequency distribution table below. First, calculate each data of the midpoint or the class mark in column 3. Use the formula LB plus UB all over 2, where LB represents lower boundary and UB as upper boundary. 1 plus 300 all over 2 equals 150.5. 301 plus 600 all over 2 equals 450.5. 601 plus 900 all over 2 equals 750.5. 901 plus 1,200 all over 2 equals 1,050.5. 1,201 plus 1,500 all over 2 equals 1,350.5. 1,501 plus 1,800 all over 2 equals 1,650.5. 1,801 plus 2,100 all over 2 equals 1,950.5. This time, let us calculate each data of fx column by simply multiplying each frequency to each corresponding midpoint or class mark. So, 2 times 150.5 equals 301. Next, 1 times 450.5 equals 450.5. 1 times 750.5 equals 750.5. Then, 18 times 1,050.5 equals 18,909. 16 times 1,350.5 equals 81,030. 2 times 1,650.5 equals 3,301. Lastly, 66 times 1,900.5 equals 128,733. We will need the summation of fx, so let us take the sum of the data in fx column, which yields to summation of fx equals 233,475. Finally, the CF column. Start copying the frequency with lowest class interval. In this case, 2. Then add 2 to the frequency of the next class interval, which gives 3. Then 3 plus 1 is 4. 4 plus 18 is 22. 22 plus 60 is 82. 82 plus 2 is 84. Lastly, 84 plus 66 equals 150. Note that the last data for cumulative frequency should be equal to n. Now that the table is already complete, let us write the given. What is the value of the summation of fx? Awesome! Summation of fx is 233,475. How about the value of n? Exactly. N is 150. Next, write the formula. X bar equals summation of fx over n. Substituting, we will get x bar equals 233,475 divided by 150. Again, let us use the calculator to solve. Input, 233,475. Division symbol, then 150, press equal sign. Then SD, the answer is 1,556.50. For smartphone calculator, input 233,475. Division symbol. Then 150. Press equal sign. The answer is 1,556.50. X bar is 1,556.50. This means the average electricity bill of the selected households in Malinta for the month of April 2021 is 1,556 pesos and 50 centavos. How are you doing so far, grade 10 students? Can you still follow? Nice! If you have questions, feel free to type it in the comment section. Let us now calculate and interpret the median using the same table and values of the previous example. Recall that we have 3 steps to follow to solve for the median. First step is to complete the column of the cumulative frequency. Since we have already constructed the frequency distribution table from the previous example, we can now proceed to the next step, which is determining the median class. And over 2, what is the value for n? Great! It is 150. Divided by 2, we obtain 75. Now, look at the CF column and find a value greater than or equal to 75 for the first time. It is 82. Nice. So, we can take the interval 1,201 to 1,500 as the median class. This means we can now proceed to step number 3, finding the median using the formula. Writing the given, we have n over 2 equals 150 over 2 yields to 75. L sub MC is 1,200.5. Less than cumulative frequency equals 22. F sub M is 60. And I is 300. We can now write the formula. X tilde equals L sub MC plus the quantity of N over 2 minus less than CF all over F sub M times I. Substituting the given values, we have X tilde equals 1,200.5 plus the quantity of 75 minus 22 all over 60 times 300. Again, let us call our friend Mr. Calculator to help us solve. Input 1,200.5 plus symbol, open parentheses, fraction T, input 75 minus 22 on the numerator, 60 on the denominator, close parentheses, type symbol, then 300. Press equal sign, then SD. The answer is 1,465.50. For smartphone calculator, input 75 minus 22, then equal sign, division symbol, 60, then equal sign, times 300, equal sign plus symbol, then 1,200.5, press equal sign, the answer is 1,465.60. X tilde equals 1,465.50, or the median of monthly electricity bill of selected households in Malinta for the month of April is 1,465 pesos and 50 centavos. Are you having fun in today's lesson? React hard if you can still follow. At this point, let us have the example for mode of group data. Calculate and interpret the mode using the same table and values of the previous example. Recall that we have 3 steps to solve for the mode. Like the median, we need to complete the column of the cumulative frequency. Since we have already constructed the frequency distribution table from the previous example, we can now proceed to the next step, which is determining the modal class. In this case, we have to take the highest frequency in the distribution table. That is 66, which is found at the class interval 1,801 to 2,100. The modal class is already determined. That would lead us to step number 3, finding the mode using the formula. But let us state all the given first. L sub MO is 1,800.5. A can be solved by getting the difference of the frequency of the modal class from the frequency before the modal class. So, 66 minus 2 equals 64. B can be solved by getting the difference of the frequency of the modal class from frequency after the modal class. So, 66 minus 0 equals 66. Lastly, I is 300. Continuously, we write the formula. X hat equals L sub NO plus the quantity of A over A plus B times I. Substituting all the values, we obtain X hat equals 1,800.5 plus the quantity of 66 divided by the sum of 66 and 64 times 300. Now, grab your calculator. Input 1,800.5 plus symbol, open parentheses, fraction P, input 64 on the numerator, 64 plus 66 on the denominator, close parentheses, times symbol, then 300. Press equal sign, convert it to decimal, press SD. The answer is 1,948.19. For smartphone calculator, input 64. We divide 130 from the sum of 64 and 66, then equal sign, multiplication symbol, then 300, press equal sign, plus symbol, then 1,800.5. Press equal sign. The answer is 1,948.19. Thus, X hat equals 1,948.14. The mode of monthly electricity bill of selected Malinta households is 1,948 pesos and 19 centavos. How are you feeling right now, grade 10 students? Feel free to press the react button. Also, if you have questions, kindly drop them in the comment section. Alright, let us now check how well you understand the lesson with this activity. Your task is to choose a reaction that corresponds to the correct answer. Just hit like, love, or haha. You have 5 seconds to choose your reaction. Are you ready? Let's start. Refer to the given table at the right side of your screen to answer the following questions. What is the mean for the number of hours spent in playing Mobile Legends? Is it like, love, or haha? 5 seconds, go. Time is up. If you've hit the like react button, way to go, you are right. Let's have the next one. What interval is the median class? Is it like, love, or haha. Your 5 seconds starts now. Time is up. If you've hit the haha react button, good job. That is correct. Next. What is the median? Is it like, love, or haha? You've got 5 seconds. Go. Time is up. If you've hit the haha react button, nice. You're right. Let's proceed to the next one. What interval is the modal class? Is it like, love, or haha? 5 seconds. Go. Time is up. If you've hit the like react button, you're correct. Next. What is the mode? Is it like, love, or haha? You've got 5 seconds. Go. Time is up. If you've hit the love react button, perfect. You're right. Let's move to the last question. The mean of the number of hours students spent playing Mobile Legends is 13. What does this mean? Is it like, love, or haha? 5 seconds. Go. Time is up. If you've hit the like react button, excellent. You are correct. Now, to sum up our lesson for today, measures of position give us a way to see where a certain data point or value falls in a sample or distribution. Other statistical measures, like the measures of central tendency, may be used to describe a distribution. At this point, let me discuss to you some of the frequently asked questions. How do we know which formula is appropriate to use in our data? It depends on the data and purpose of presentation of your data. If your research data requires you to interpret the rank or locate its position in the distribution, use the formula for the measures of position. However, if you have a research data that requires you to select a central value that describes or represents the whole set of data, use the formula for the measures of central tendency. Of course, for your weekly homework, answer the following questions. Write your answers with complete solutions on your notebook. Before we end this session, take note of this line from Albert Einstein. A person who never made a mistake never tried anything new. Alright? Thank you so much, grade 10 students, for joining us today. This has been your mathematics live streaming teacher, Mr. Junior Cesar G. Plesto from Malinta National High School. See you again next time. Keep safe and healthy.